Scientific inquiry often gives rise to mathematical problems. Um, these problems can be of the form of systems of equations or systems of differential equations. They may involve approximations in the form of regression, trying to fit a curve to data, or Fourier approximation or approximation of a complex function by polynomials, and so on. And very often these problems do not have a closed form solution. Solving, say, for example, a polynomial equation of degree 7, there's no formula for it, and we need to find numerical solutions. So this is what numerical analysis is about: developing the algorithms and methods of solving mathematical problems using numerical techniques. In order to find numerical solutions to scientific problems, we need a computational environment. And the environment we're going to use is MATLAB. MATLAB has its own language, and the syntax of this language is very similar to Python. So this would be another string to your bow, and we are going to use this to solve problems. The code can easily be translated into Python. From Python to MATLAB, from MATLAB to Python is not difficult at all. So we will commit ourselves to using the MATLAB computational environment. I have written a complete set of notes on the MATLAB environment, and it'll start off just discussing MATLAB in general, and then we will get started. I've made a couple of videos about this, and we will work through this, and we will use MATLAB firstly as a calculator, and then we will write our own scripts in the form of programs or functions to execute commands. I'm assuming then that you have got MATLAB available. This will be in the computer laboratory, or that you got installed on your own computer. And you need to first launch MATLAB from that start button. When MATLAB initiates, you will see something like this. These are previous commands that I've had. And the layout can be adjusted here. And I'll make a little video to show you how to get around that. But these are the previous commands that have been written on my computer. You can clear all of these. This is the command window, and this is the command prompt, which is tempting you to issue commands, which MATLAB will then execute, and the variables that you introduce will appear here. So if you have MATLAB up and running, then in the command window, type v is equal to 3 plus 5. What that is doing is making a variable which we call v, small v, and we have stored the number 3 plus 5 in it, 8. So in the workspace, you will see that there's a variable name v, and the number 8 is in it. If you type now v equal to 10, it'll change what is in that variable v. It has 8 in it. Now you tell it v equals to 10, so the 10 will overwrite that. If you type who's in the command window, you see what the variables are. In this case, there's just the variable v. It's taking up 8 bytes. That's got nothing to do with this number over here, of course. And it tells you what it is. It's a double precision array. And you can see this in the workspace. So your MATLAB workspace should look something like this now. There you've performed this calculation. You've made the variable v. And if you look over here, there it is. There's in the workspace, there's the variable v with the value 8 stored in it. And this is your command history. It's a history of the commands that you have issued to MATLAB. These are ones which I've done previously. Cleared all the variables first. CLC clears the command window, and then typed in v is equal to 3 plus 5. So everything is available for you to inspect. The other arithmetic operations are as you'd expect. Subtraction, 3 minus 5. The answer is minus 2, and we did not say m or v or something equal to 3 minus 5. We just typed in 3 minus 5, so MATLAB makes its own variable called ans. And in that variable, it stores minus 2. Multiplication is this little asterisk, and division as you'd expect. And exponentiation, 3 to the power 5. This is a little bit different from Python. 3 to the power 5, and it'll give you the answer to that stored in the variable p. These variable names, by the way, you haven't got a complete free hand with it. You've got to start off with a letter, and then any number of digits you like, and then you can use underscores. And by the way, it's not that it's going to come up very often, but it only uses the first 31 characters. It just will ignore the rest that you type in as a variable name. So that's a limit on the size of the variable names that you can use. Of course, MATLAB is case sensitive, and you can clear all the variables with the command clear. And just a word here, when we type x equal to 34, we're making a variable x, and we're storing the number 34 in it. Because we can make a character array or a string array. And now if you have a look at it, here in the first one we've got the number, whereas stored number 34 stored in x. We called capital X. We've put these little inverted commas next to it to tell it that this is a string array or a character array. We'll talk more about this a bit later, but you can always find out what variables you have. The capital X, which we formed here, is a character array, whereas little x here has got a number, a double precision number stored in it. We'll talk about these strings later, but let's just get used to this with a problem which we'll set ourselves. We put a certain amount into an account, it attracts an interest rate of 13%, and the interest is accumulated at the end of each year. So let's use MATLAB as a calculator to see what we've got in the balance after 4 years. So we clear the command window. CLC clears the command window, and now we're going to make variables, and we're going to call them balance and year, interest and rate. Some of these are fixed. The year will change, the balance will change, the interest rate is fixed. The interest rate is fixed, but the interest will change. So here we go. We make the variable balance, and we store into it the number 1, 2, 3, 4. That's what we start off with. This is year 1, and then the rate is 13%, 0.13, 13 over 100. Then, with interest that you get is on the balance, and it's the balance times the rate. So that's the actual interest that you get after 1 year. So now MATLAB has produced the balance. We added the interest to the previous balance, and the default format that MATLAB uses is the short format. That is, it's correct to 4 decimal places. Let's have a look at the other formatting options which are available to us. So if we type help format, we can see the formatting options available to us. Format short is the default one. It's correct to 4 decimal places, and long if you want to see all 15 decimal places. It is working to 15 places. So when you format short, it's not losing any accuracy. It's just revealing correct to 4 decimal places. Let's format bank if we want to use MATLAB for financial calculations. Also, the formatting compact, it suppresses that extra line. So some people like to have a space between the lines. If you want to make it compact, then format that. So now, having changed the format, there's our interest. And now we're going to repeat that calculation. We add the interest to the balance. And that is the balance then at the end of the first year, beginning of the second year. And it's important to understand what's going on here with this equal sign. This is not the mathematical equality. What this is saying is that the new balance is the old balance plus this amount which we've computed. Computer people like to use this back arrow. That is, we had a certain amount stored in a variable, and now we're replacing what was stored there by a new amount. Now the variable balance has changed. We're storing a different number in it. We change the year. We add 1 to the old value of the year to get the new value, which is now we're into year 2, and we compute the new interest. Then once we've got the new interest, we update the balance. We update the year, and then we carry on in this way, computing the interest, adding it to the balance. So we update the balance for as long as we require. We want to go to year 4, and then we get the balance after 4 years, and we can then confirm this. This is the interest rate was 13%, 0.13, and so the new balance, we could have done this right from the beginning, just using compound interest formula, but this was just to illustrate this process. Of course, we won't be using MATLAB as a calculator like this. We will be writing a script to tell MATLAB to do this for us. Well, here's a little exercise that you should try to see if you've understood what has just happened. This is just how to make variable names. And here are 2 problems similar to the one that we addressed previously. Experiment with complex numbers, and you can get the real and imaginary parts of a complex number. And this little exercise is going to lead you into that intriguing mathematical object called the Mandelbrot set. So follow what is stated here. Start off with a C and iterate as so. For example, here is a C 0.2, the real part's 0.2 and the imaginary part's 0.3. And keep on iterating as shown. Carry on iterating. Is it possible that this sequence of complex numbers is bounded, or does it just diverge? I want you to experiment with that. If you iterate 200 times, it carries on in the way that we've just done it, and you've now, in the command window, written a deterministic loop, a for loop. You can do that with MATLAB. You don't have to write a program. You can just do it right in the command window. So if you iterate those previous steps 200 times, it seems to be converging to a complex number. And you'll discover that for various complex numbers, if you iterate many times, the sequence will diverge and sometimes it'll converge. And the idea behind the Mandelbrot set is to plot those complex numbers for which that sequence converges. So try it for another one and see what happens. You see that this some of them converge to a number and some of them don't. And it'll generate this very, very intriguing object called the Mandelbrot set. So just this is not really to explore the Mandelbrot set, it's just to explore the features of MATLAB, in particular complex numbers. Remember Newton's method for solving an equation, for finding the root of a function. So you trying to solve f of x equal to 0, you make an initial estimate, and then you make an adjustment as shown. So try that out for a certain function. Say we're trying to find root 2 by solving 2 minus x squared equal to 0. So we make the function 2 minus x squared, That's a quadratic, upside down quadratic, and then take an initial guess at 1, and then make an adjustment, take that as your new input, and so on. So you can carry on like that. You see that the sequence is converging to 1.41 and some change, square root of 2. So you can check that in MATLAB, of course, the square root of 2. Now you tried full finding the cube root of 10. This is just an exercise which will illustrate the function's remainder function and the greatest common divider. So if you start with an A and a B, 168 and 32, you can get the remainder. The syntax is the remainder when you divide A by B, when you divide 32 into 168. And there comes the C. And then you can iterate until you get a remainder of 0. Or you can use the MATLAB function greatest common divisor. So you try that out for various pairs of numbers.